recording this at work, so I'm hoping they're being really loud out there. I'm hoping you're not hearing that. I hope the mic isn't picking that up. We're going to talk about section 4.2, trigonometric ratios of any angle. This took me a whole class just to explain the first part of it, so hopefully we can do it a little quicker this way. I'm not sure. So we have to do a little bit of review before we get into what they're talking about. So first off, we have to remember back, we're going to talk about sine, we're going to talk about cos, and we're going to talk about tangent. So hopefully you remember that sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. What you may not know is that there are 3 reciprocal ratios. So, for example, the reciprocal of sine is actually called cosecant. We shorten that to CSC. So cosecant is the reciprocal of sine. So it is hypotenuse over opposite. Cosine's reciprocal is called secant, and we abbreviate that SEC. So it is hypotenuse over adjacent. And then for tangent, it is cotangent, which we abbreviate just to COT. And that would be adjacent over opposite. So the basic trig ratios you already know are sine, cosine, and tangent, and then we have the reciprocals, which are just exactly the opposite, the flip, the reciprocal of the other one. Now, whenever we draw a terminal arm, so we're going back to that last section where we talked about this idea of terminal arms. And I need to erase this. This is the problem with not having big giant whiteboards to work on. So if I have here and I draw a terminal arm, let's say I put it here. That terminal arm, I can make a triangle with it. When I make a triangle, I always draw it to my x-axis. Always, 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 always. You never have a terminal arm. I don't care what section, what quadrant it's in. You never have a terminal arm and make your triangle over to the y-axis. That is a big no. Don't do that. You always draw it to your x-axis. Okay, that's very important. Very, very, very important. Now, what that does is that creates a right angle triangle where that terminal arm becomes your hypotenuse. They don't use the word hypotenuse anymore. They use the word resultant. That comes from drawing vector diagrams back in physics. So they would represent it with a letter R. I don't care whether you think of it as hypotenuse, resultant, doesn't matter. It's the same thing. Okay, this would be your x, and this would be your y. So if you were doing what is sine, you need to know sine of which angle. What angle are we talking about? Whenever we put a triangle into a Cartesian plane, we are always talking about the angle that is inside the triangle that is closest to the origin. It's closest to where your x and y axis cross. This is known as your reference angle. We would never be talking about the angle up in this corner up here. Never would we talk about that one. We always talk about this one in terms of being our reference angle. So sine is opposite over hypotenuse. So that would be y over r. And so the reciprocal, which is cosecant, would be r over y. Now technically I should put cosecant theta. I'm just lazy and I end up dropping it. So cos of theta is adjacent over hypotenuse. So that would be x over r. So secant theta would just be the reciprocal, r over x. Tangent is opposite over adjacent, so it would be y over x. And so cotangent is x over y. It's just the reciprocal. Now, in this first quadrant, for the x, we start at the origin and we go forward. For the y, we go up, meaning they are both positive. So when I look at my trig functions, all of them work out to be positive. Now, if, I don't know if I can do this, if, okay, why do you not want me to? Okay, let's change it then. It's being picky. Okay. If instead of it being in that quadrant, if your terminal arm was here, and by the way, this is quadrant 1. If your triangle was here, so your terminal arm is that hypotenuse, your reference angle is always here. This time, instead of going forward on the x-axis, you're going backward on the x-axis. So the x is negative, but you're going up, right? You're going in the positive direction for the y, so the y is positive. The resultant, or the hypotenuse, is always positive. So then, if I go to do those ratios, they all work out to be the same. Sine is still opposite over hypotenuse. It's still y over r, and it's positive. Cosecant is still r over y. Nothing's changed. But when I look at cos, it is adjacent over hypotenuse. But the adjacent is now a negative x. So it's negative x over r. Secant is r over negative x. If I look at tangent, tangent is opposite over adjacent. But now that's negative, and so the reciprocal would be negative x over y. So what you should notice is that sine and its reciprocal, because they always go together, sine and its reciprocal are the only things that are positive about this. So in this quadrant, sine and its reciprocal are the only thing that's positive. This is quadrant 2. If we have the terminal arm down here, this is known as quadrant 3. And again, my reference angle would be here near the origin. And so if I look at my x, I'm starting at my origin, I'm going back x, and I'm going down y. So now the y is negative as well. The resultant is always positive, always. All right? So when I go to look at my ratios, sine of theta is negative y over r. So it's negative, which means the reciprocal is r over negative y. Cos is adjacent over hypotenuse. It is negative x over r, same as it was before, and so it's r over negative x. But when I get to tangent, tangent is opposite over adjacent, so it's negative y over negative x. But if you have a negative over a negative, that makes a plus, right? So the same thing here. I would have a negative over a negative, which makes a plus. In this quadrant, in the third quadrant, tan and its reciprocal are positive. So by process of elimination, if I then do the last quadrant, which is quadrant 4, if I put a triangle in here, again, my reference angle would be here, but I'm going forward x, but I'm going down y, and my resultant is here. So sine is opposite over hypotenuse, so it's negative y over r, which we have. So the cosecant is r over negative y. Cos, though, is positive x over r, so it's positive, which means secant is r over positive x, so it's positive. My tangent has now changed, because tangent is opposite, which is negative y over positive x, so now it's negative again. And the same thing, the same thing over here. It would be positive x over negative y. So notice the only thing that's positive is cos and its reciprocal. The way to remember that, and different teachers kind of teach it differently. I'm old school, obviously. And so I remember it by something called the CAST rule. CAST because C-A-S-T spells cast. The only problem with that is you have to remember that the C doesn't start at quadrant 1, it actually starts at quadrant 4, and you go around counterclockwise. Some teachers have an acronym like ASTC means something. They have a little sentence to go along with it or something. I just remember the CAST rule. You can remember it however you want. So quadrant 4, cos and its reciprocal are the things that work out to be positive. All things in quadrant 1 are positive. All right, so I've given you a lot of information. We're going to look at example 1 on page 195. And quadrant 1, example 1 on page 195 asks us, just a second, whoa, what am I doing? Asks us to give the trig ratios for a given situation. Just get rid of all this. Okay. And so it asks for sine, cosecant, cosecant, tan, cotangent. But all it gives us is it gives us a point of -5 and -12. And they tell us, they put a lot of language in there. They say the point -5 and -12 lies on the terminal arm of an angle theta in standard position where theta is less than 0. Determine the exact values of the 6 trigonometric ratios. Don't freak out about all that language. Take all that language away. You have a point -5, so back 5 and down 12. You have a point, let's say that's here. I can draw a line from the origin to that point. That's a terminal arm. Okay, that's a terminal arm. I can make the triangle. Always draw to your x-axis. Okay, and I know that I went back 5 and I went down 12 to get there. Now, I can figure out what the hypotenuse side is. I can figure out what that is because I know Pythagorean theorem. Pythagorean theorem tells me that -5 squared plus -12 squared equals my resultant or my hypotenuse squared. So 25 plus 144 equals r squared. So 169 is my r squared, so my r is 13. So I know that this answer is 13. Remember that your resultant or your hypotenuse is always positive. So now they want to know about those trig ratios. I can do that. They want to know sine. Remember, your reference angle is always the angle inside the triangle near the origin. So if I want to know what sine is opposite, which is -12, over hypotenuse, which is 13. Cosecant is the reciprocal of that. Cosine is adjacent over hypotenuse, so secant is the reciprocal of that. Tangent is opposite over adjacent, so it's -12 over -5. But remember, a negative over a negative makes a positive, so it's 12 over 5. So the reciprocal is 5 over 12. Now remember, according to my CAST rule, tangent and its reciprocal are the ones that should work out to be positive, and they did. The other ones all worked out to be negative. All right. Yes, I know there's a lot of information in this. If you're thinking, wow, that's a lot, I know it is. Hopefully you can just watch a piece of this video at a time, because I'm not done. So In calculus, in trig, there are certain triangles that just seem to show up a lot. Because in architecture, these angles work the best, are the strongest, different reasons, but there are 3 triangles that show up a lot. That is a triangle that has a 30-degree angle in it, a triangle that has a 60-degree angle in it, and a triangle that has a 45-degree angle in it. All right, so these are triangles you just have to know. In a 30-degree triangle, the opposite side is always 1, the hypotenuse is 2, and the adjacent side is root 3. In any 30-degree triangle, when you look at the opposite side and compare it to the hypotenuse side, you will always get a fraction of 1 over 2, even if you have to reduce it. So if you had a triangle and you had 5 and 10, this side was 5, this side was 10, and you wanted to know what that angle was. Well, because the opposite over the hypotenuse side is 5 over 10, which reduces to 1 over 2, you know that this angle has to be a 30-degree angle, because in a 30-degree angle, the opposite side over the hypotenuse side always make 1 over 2. I don't know who discovered this, somebody who must have been very bored at some point. And this side always works out to be root 3. In a 60-degree triangle, we're going to have the same numbers, but they're in different places. The 2 is still the hypotenuse, but now the adjacent side is 1, and the opposite side is root 3. In a 45-degree triangle, this side is 1, this side is 1, and this side is root 2. These are things you just have to know. So I would write those triangles down somewhere. You just have to know those triangles. Because in example 2, they say find the exact, meaning no rounding off, meaning there will be radicals in your answer. Find the exact primary, and we'll talk about what that word means in a minute, primary trig ratios for 120 degrees. Now, when they use that word primary trig ratios, they mean just the 3 you normally do, sine, cosine, tangent, not the reciprocals. So primary just means sine, cosine, and tangent. So we are looking for what is sine of 120, what is cos of 120, and what is tan of 120. But they want the exact answer. If you go to your calculator and you put sine of 120 in your calculator, you're going to get, well, actually for 120, you're probably going to, no, for 120, you're going to get a really weird long decimal answer, which means you're going to end up rounding it off. They don't want you to do that. So here's how we do this. I'm going to give myself some space. We know that this is 0 degrees, this is 90 degrees, this is 180 degrees. So 120 degrees, I would start at 0, go to 90, and go another 30 degrees. That is 120 degrees. But remember, so there's my terminal arm. You always make your triangle down to your x-axis, which means your reference angle is the angle inside the triangle right here. But I don't know what that is, but I can figure it out, because I know that from 0 all the way to here is 180 degrees. And I know that from here just to my terminal arm is 120 degrees. So if I want to know just from here to here, I'm going to do 180 minus the 120. That's going to give me 60 degrees. So this reference angle is a 60-degree angle. So 120 degrees is a 60-degree triangle put in the second quadrant. So with a 60-degree triangle, I know that the adjacent side is 1. I know that the hypotenuse side is 2. I know that the opposite side is root 3. Now, all I need to worry about is what is positive and what is negative. The resultant, the hypotenuse, is always positive. But if I start at my origin, I am going back 1 in this quadrant, so it's a negative 1. I am going up root 3, so it's a positive root 3. Now, they want to know the exact primary trig ratios. So if I want to know what is sine of 120, sine is opposite over hypotenuse. I don't know why I put a negative there. I shouldn't. It's just positive. It's opposite over hypotenuse. So it is root 3 over 2. That is the exact answer because root 3 is like 1.4 and it goes on forever and ever and ever. I don't want to round it off. I'm going to leave it in simplest radical form. Cos of 120 is adjacent over hypotenuse. So that is negative 1 over 2. Tan is opposite over adjacent. So that is root 3 over negative 1, which you could just write as negative root 3. Now again, remember my cast rule, C-A-S-T. This triangle is in the second quadrant where sine is the only thing that should work out to be positive. And look, root 3 over 2 is positive. The other two work out to be negative. It all comes together. It all comes together. All right. So let's look at example 3. Let's look at example 3. It's on page 197. And they want to know what is the exact answer for cos of 5 pi over 4. Now we could work this in radians, but I never like working in radians. It's just not my favorite thing to do. So I would actually switch, and this is why it's important to know how to switch from one unit to another. 5 pi over 4. Remember, pi is 180 degrees. So if I want to figure out what this is in degrees, I can just do 5 times 180, and I can divide it by 4, and it tells me 225. So cos of 225 degrees. And they want to know an exact answer for that. So again, I'm going to, this is 0, this is 90, this is 180. I didn't put it in the middle because I know I need to be down in here. So here we go. I am going to get rid of that. I'm going to start at 0, and I'm going to go, oh, I hate that. I'm going to go to 0, I'm going to go to 90, I'm going to go to 180, and I'm going to go forward enough more to do 225 degrees. It's in this quadrant right here, and we always make our triangle to the x-axis. So I know from here all the way to here is 225, but I want just the reference angle. I want just here. So how do I figure that out? Well, I know from 0 to this axis right here, that's 180 degrees. I know that all the way to the terminal arm is 225. So if I do 225 minus 180, that gives me 45 degrees. This is a 45-degree triangle. So if that is a 45-degree triangle, and it's here in this quadrant, right here, I know that my opposite and my adjacent sides are both 1, but based on the quadrant it's in, I'm going back 1 and I'm going down 1. Those are going to be negative. The hypotenuse is always positive. So now if I want to know what is cos of 225, cos is opposite, which is negative 1 over hypotenuse, which is root 2. Now they leave that as the answer in the textbook. I don't like that. You are never supposed to leave a radical in the denominator. So way back in grade 10 and in grade 11, we talked about rationalizing a denominator, which just means getting the radical out of the bottom. To do that, we just multiply it by itself, because root 2 times root 2 is the square root of 4, which is just 2. But whatever I do to the bottom, I have to do the top, so I have negative root 2 over 2. Now again, thinking about positives and negatives for a second, we know that in the third quadrant, CAST, tan is the only thing that should work out to be positive. So if I'm doing cos, it should be negative, and it is. So that's my answer. Cos of 225 is negative root 2 over 2. So they ask for another one. And so the next one is cotangent of negative pi over 6. Now again, I am not a fan of radians, so I just because I think better, negative pi over 6 would be negative 180 divided by 6. It ends up being negative 30 degrees. 180 divided by 6, 30, and it's negative. So negative 30 means I'm starting at 0, but because it's negative, I'm going back 30 degrees. I'm just going back 30 degrees. I always draw my triangle to the x-axis. Well, that's handy. I already have the reference angle. So in a 30-degree triangle, the opposite side is 1, the adjacent side is root 3, and the hypotenuse side is 2. 1, 2, root 3. Thinking about positives and negatives, I'm going forward root 3, so it's positive. I'm going down 1, so it's negative, and my hypotenuse is always positive, so it's 2. So cotangent. Tangent is opposite over adjacent. So cotangent is adjacent, which is root 3, over opposite, which is negative 1, which is just negative root 3. And that's my answer. The last example I did was part of example number 4 on page 198. On page 198, they give you clues, and you actually are going to work backwards. So they tell you this information. They tell you sine of theta is negative 1 over root 2, and cos of theta is positive 1 over root 2, and they want to know what quadrant would this be in, and based on that, what is tan of theta? So, first off, sine is negative. According to my cast rule, all things are positive in this quadrant. Well, sine's not positive, so it's not in that quadrant. In this quadrant, sine should be positive. Well, sine's not positive, so it's not in that quadrant. So it's either in the third quadrant or the fourth quadrant. Now, continue looking. Cos is positive. Well, in the third quadrant, tan is the one that's positive, not cos. So it can't be in that quadrant. So that means it has to be here in this quadrant. Now, sine is opposite over hypotenuse. So that is 1 over root 2. Now, one of those has to be negative. The hypotenuse is never negative, and because we're going down, this would be negative 1. Cos of theta is positive 1 over 2, and remember, it's the adjacent side, so it would be 1, and it's positive 1. You're going forward 1. So what is tan? Tan is opposite, which is negative 1, over 1. So it's just negative 1. Now, if you wanted to know what is that angle, well, 1, 1, and root 2, that angle is a 45-degree triangle. So we always measure our angles starting at 0 and coming around. So if we know that this angle in here, if we know that that angle in here is a 45-degree angle, then here would be 360, because all the way around is 360, minus 45. So theta is actually 315 degrees. So you could even figure that out if you wanted to. All right, so that is the end of this section. I know it's a lot of information. So take your time and maybe watch this 2 or 3 times. Don't watch it all in one sitting. I hope you didn't. So I hope this helps.